Imagine a WhatsApp group. Someone posts a message, everyone in the group sees it. The sender does not need to know who is in the group, they just post, and whoever is listening receives it. That is exactly how an event bus works. In our naive code base, when a date is selected, what happened? We directly updated the input hard coded. What if we need something else to know? What if our form validator need to check the date? What if analytics needed to track it? You would have to add more code inside our date picker for every new requirement. That is tight coupling and it does not scales. The solution is publish subscriber or pub/sub. That is our event bus. A date picker publishes an event, says, hey, date was selected. It does not know or care who is listening, it just announces it, and anyone who cares, the subscriber to that event, the input subscriber, the validator subscriber, analytics subscriber, the event bus is just a middleman who receives the announcement from publisher and delivers to the subscriber. This is our event bus or our pub/sub pattern. You have already used it, you don't know. You have the DOM events, that is the same pattern. When you click a button does not know that handle click exists. It just fires a click. But the browser's event system deliver the functionality. We are doing the same thing here, a tiny focused version for our date picker. Now we will rewrite our date picker. Let's create a new file inside our call, eventbus.js. Let's create our event bus. And first we have our constructor to initialize a value. We will need a listener. So let's say listeners, and I'm going to use map here. I'm using a map instead of object because map has more properties and that will help us to get and set some values. And here is how we will store values inside our map. So we'll have the key as an event and then array of callback functions. So here how it will work. We will have array for all the functions inside our object. So this is an event. So whenever this event is fired, all the callbacks will be called. So we will have multiple events with array of functions. Now let's add our first method on. It takes two parameter, event and callback. This event, it will subscribe to an event. So this is how we will use it. So we'll say eventbus.on and then date select. So this is how we read it. On date select, here is the callback. Whenever this event is fired, call this callback. This is how we read it. And this will subscribe to an event. So first we will check if there is any event for this. So we'll check this dot listeners dot has event. So if this event exists, and if this event does not exist, we will simply return early, or in this case we will just initialize the event with an empty array. So we'll say this dot listeners dot set event an empty array. Then we'll say this dot listeners dot get event, and we will push all the values. We'll push all the callbacks to this empty array. We'll say callback. Now here is important part. We will return a unsubscribe function. So return unsubscribe function, event and callback. Now why we are returning this? Because for memory management, when you are done listening, you need to clean up. This makes it easy. Next we have emit method. It takes two parameters, event and data. It will emit an event. So when we want to use this emit, we will say EventBus dot emit date select. So when we emit this event, means when we fire this event, our event bus will go and check if there is any event exist in our listener, and then it will call all the callbacks for that particular listener. So in here we'll say if this dot listeners dot has event, and we are checking the null. So if there is no event, it means no one is listening to, then we will simply return. Else we'll get all the callbacks. But here is a subtle information, and it is a trick that we are not going to directly use all the event callbacks. We are going to copy to an array. So we'll say this dot listeners dot get. We will get all the listeners for this particular event, and then we'll callbacks dot loop for each callback. And then we will call this callback with the data. And here is one more important thing. We will wrap it in a try and catch block. Why? So let's say one callback throws an error, then it will disturb our entire callback functionality. So one bad callback should not break our functionality. So we will just handle using the try catch, and whatever error it gets, it will be logged out here. This is called defensive programming, assuming things will fail and we handle it gracefully. So we'll say console.error EventBus error in event handler, and here is the error. So this is our emit method. Next we have off method. Off, it will unsubscribe from an event. So it will take two parameters, event and callback. And first thing we will check if there is a listener for this particular event, means like if there is any event inside our listeners. So this dot listeners dot has event. If there is none, then we return early. Else we will get all the callbacks. Let's say this dot listeners dot get event. Then we will find the index for that particular callback that we want to remove or unsubscribe. We'll say callbacks dot index of callback. And if we find the index, then we will remove it. Callbacks dot splice index and 1. So it will remove the callback from the callbacks array. And there is one more check we will add. So if we are removing the callback and the callback array gets empty, then we'll check length equals to 0. Then there is no point of keeping this event. So we will simply remove this event. So we'll say delete event. Next we have once method. This subscribe to an event only once, and once it is fired, it will remove itself. So we can write it like this: once event callback, and we will wrap this callback in a wrapper function. We'll call it here callback with the data, and then we'll say this dot off event, this off to unsubscribe this particular callback. So we'll pass it wrapper. We'll pass it here callback, not the wrapper. So we'll pass the callback. This one, just remove it from the callback array, and here we'll say this dot on, because we have to call it once. So we'll say event and then wrapper. So this on will register this wrapper one time, and off, okay, we need to pass the wrapper because we are registering the wrapper, not the callback. So it will register this wrapper once, and once you call this callback, it will remove this from events array, the callback array for particular event. Next we have clear method. This clear method remove all the listeners, or it will remove a particular listener for a it will remove listener for a particular event. So we'll say clear event. It is an optional parameter. We'll check if there is an event passed. We'll check this dot listeners dot delete, and we will delete this event. And if we don't pass any event, we can simply say this dot listeners dot clear. So it will remove all the listeners. Next we have listeners count. So we can get number of count of callbacks for a particular listener, or all the callbacks from our listeners event bus. We'll say listener count. We pass it event, a particular event. If we want to get number of count for that, we'll check if event will return this dot listeners dot has event, then we'll say this dot listeners dot get event dot length, else will return 0. And if we don't pass the event, we will count how many listeners are there for particular event. We'll check this dot listeners dot for each callbacks, we'll say count equals to count plus callbacks dot length, and then we will return count. So our event bus is ready. We have written around 75 lines of code, but it changes everything about how component communicates. No more hard code callbacks, no more tight coupling, just events flowing through a central bus. But we still have scattered state variables everywhere. So when we are rewriting this one, we will write a state manager that will control all the states. If we check our naive code, we have these variables, the states In the global, we don't want that. For our new version, we want to have a centralized state. So in next episode, we will start writing our state manager. EventBus is done. We have around 76 lines of code, but it changes everything about how components communicate. We have no more hard-coded callbacks, no more tight coupling, just events flowing through a central bus. But we still have scattered state, variables everywhere. Next episode, we fix that with state manager, our single source of truth. I see you in episode 5.